Have you ever accidentally deleted something on your device and wished you could undo your mistake? Wouldn't it be great if you had a time machine to go back and undo your mistake? While humans can't yet travel back in time, programmers working on projects can do something quite like it. They do this using a system called version control. As a programmer, you'll be working with many files in your project, and it's important to keep track of the changes being made. Version control is a system that records all changes and modifications to files for tracking purposes and is essential to your day-to-day development activities. In this course, you will become familiar with version control and how it relates to development. By the end of your studies, you'll understand what version control is, how it works, and how it is used. There are both centralized and distributed control systems available, and you'll examine the different types of workflows available. Conflict resolution is an important aspect of version control, as it helps users manage file and version conflict issues. You'll get to explore popular methods of version tracking using version control technologies like Git and GitHub, and you will learn how to create and clone a repository in GitHub. In addition, you will become familiar with Git concepts such as add, commit, push and pull, branching and forking, diff, and blame. As well as focusing on version control, the course also explores the use of command line syntax with an emphasis on Unix commands. There are many videos in your course that will gradually guide you toward that goal. Watch, pause, rewind, and rewatch the videos until you are confident in your skills. Then you'll be able to consolidate your knowledge by consulting the course readings and put your skills into practice during the course exercises. Along the way, you'll encounter several knowledge quizzes where you can self-check your progress. You're not alone in considering a career as a web developer, and the course discussion prompts enable you to connect with your classmates. It's a great way to share knowledge, discuss difficulties, and make new friends. To help you be successful in the course, it's a great idea to commit to a regular and disciplined approach to your learning regime. You need to be as serious as you can about your study, and if possible, map out a study schedule with dates and times that you can devote to attending the course. Of course, this is an online self-paced program, and you can study at dates, times, and places that suit your lifestyle. However, it may help to think of your study in terms of regular attendance, just as you might have to do at a physical learning institute. You may have encountered new technical words and terminology in this video. Don't worry if you don't fully understand all these terms right now. Everything you need will be covered during your learning. In summary, this course provides you with a complete introduction to version control, and it is part of a program of courses that lead you toward a career in software development.
Communication is the most important skill for collaborating with other developers to ensure that you're on the same page when you're building products, and also so that people are keeping track of each other's timelines and the understanding of what the product requirements are consistent. Hi, I'm Layla Rizvi. I am a backend software engineer at Instagram working on Instagram calling in San Francisco. Effective collaboration is important so that we can move cohesively together on large projects with people that have a wide range of skills. As engineers actually have to collaborate with one another a lot. When we build features together, we have to work in parallel with one another to design the best features for our users. We also have to collaborate with a lot of non-engineers a lot. For example, when we built Instagram Live, we had to work with our product managers to figure out what we should build. We had to work with our user researchers to figure out what areas we should focus on to build the best products for our users. We had to work with our designers to figure out the right look and feel for our product. And we had to work as engineers to figure out what we can actually build in the timeline that we had. Communication is one of the most important skills for working with other developers. Learning how to give developers the right amount of context for what they're working on. Learning how to ruthlessly prioritize your work is also very important as a software engineer. There's always going to be an endless amount of things that you can do to improve your product. Learning which things are most important to unblock other developers or unblock yourself is the most important skill. The last thing that's really important to learn as a software developer is to accurately estimate your products. When you first start out, it'll be a little bit tricky, but over time, learning how to say how long a project's going to take and being able to explain the trade-offs is going to be very critical. The skills you need as a software developer changes from company to company a little bit. When you're at a big company like Meta, engineers are much more specialized, whereas if you're in a startup, you wear many different hats. As an engineer at Meta, we have to learn to be able to give just the right amount of context to people for what we need to get done, because we're working with people with little context on the work we're doing. There's so many engineers there. But if you're in a startup, people generally have a little more context on what you're working on, but they might not be as specialized in that area. So you have to do a little bit more learning potentially, and you have to maybe give less context to them. Some challenges I've encountered while learning to collaborate is that I have to learn how to adjust how I work with different people depending on their work preferences. Some people I work with are visual learners, so I learn to whiteboard when I'm talking to them. Some people I work with like to think before they speak, so I learn to be a little more patient when I'm talking to them, to listen to them. A skill that I'm working on learning to develop my own career is I'm learning how to work on mobile. I'm a back-end engineer, and I work with mobile engineers every single day to better build products for them. It's nicer for me to understand how they operate, how their code base works, so that we can build better things together. To learn mobile, I took an Android bootcamp class at Meta that Meta provided for backend engineers interested in learning mobile. And after I finished the course, the Android engineers on my team have been giving me small tasks and small projects for me to drive so that I can learn a little bit more about how they work. Practicing effective version control leads to better collaboration because it helps you understand why certain changes were made if you look at a commit. It also helps you context switch between different features or projects that you're working on. Effective collaboration led to a better outcome on a recent project of mine. I'm a backend engineer, and I was driving the backend parts of a key project for my team. I had to unexpectedly take time off, but I had a lot of clear commits for my code changes in Git, and I had a lot of documentation for my team, so they were able to easily pick up where I left off, and the project ended up staying on track. You should keep learning to collaborate with other people, because the more people you work with, the better products you build, because you'll get different perspectives on what you're building. It's rewarding because your product that you're working on ends up being better. The more people you work with, the more people you can learn from. And ultimately, it's rewarding because the product that you build is going to be better, because it's going to have a lot more different input and a lot more different perspectives for how it should be built.
Have you ever worked on a document, made changes to it, and wished you could have gone back to your first version a few days later? Can you remember that feeling of wishing you could travel back in time? For developers, this time machine exists, and it's called version control. In this video, you'll learn about version control's primary features and benefits. Version control is a system that records all changes and modifications to files for tracking purposes. Developers also use the terms source control or source code management. The primary goal of any version control system is to keep track of changes. It achieves this by allowing developers access to the entire change history with the ability to revert or roll back to a previous state or point in time. There are different types of changes, such as adding new files, modifying or updating files, and deleting files. The version control system is the source of truth across all code, assets, and the team itself. Let me give you an example that we're all familiar with. In word processing applications, version control functionality is available to provide users with a safety net of autosaving the document. The application creates a restoration point on each autosave to which the user can revert if required. Version control systems for coding projects tend to be a bit more complex, but their underlying functionality follows the same process. Working as a developer, you'll need to become familiar with many different tools, and version control is one of them. For developers, especially those working in a team, there are many benefits associated with version control. These include revision history, identity, collaboration, automation, and efficiency. Let's explore these in some more detail. Revision history provides a record of all changes in a project. It provides developers with the ability to revert to a stable point in time in cases where code edits cause issues or bugs. The ability to roll back to a particular version or time allows teams to work faster and deliver code with more confidence. Keeping a record of changes is great, but it doesn't have as much value if you don't know who is responsible for adding or changing a record. all changes made are always recorded with the identity of the user that made them. Combining this feature with the revision history allows teams to see not only when the changes occurred, but also who made the changes. Teams can also analyze the editing, creation, and the deletion of files on the control system. As a software developer, you will often work with a team to achieve a common goal. This can be adding new features to an existing project or creating a brand new service. In all cases, a version control system allows the team to submit their code and keep track of any changes that need to be made. Another important aspect of a version control system is something called a peer review. Developers working on a task create a peer review once the code is ready for inspection. The peer review aims to get other developers on your team to review the code and provide feedback where necessary. The ability to create and deliver code on a wide scale is complex and time-consuming. Version control helps keep track of all changes. It plays an integral role in the explosion of development operations, or DevOps, as it's commonly called. DevOps is a set of practices, philosophies, and tools that increase an organization's ability to deliver applications or services to a high quality and velocity. Version control is a key tool in this process, and it is used not only to track all changes, but also to aid in software quality, release, and deployments. You, as a developer, will usually work on a project alongside many developers and team members with other skill sets. You and your team need to be efficient to make your project a success. You and your team may work using processes from the Agile methodology. In an Agile process, a team normally plan and execute 2 weeks of work to complete, which is called an iteration. Each iteration has a list of tasks to complete before the 2 weeks ends. These tasks, while complex in some cases, are aided by having version control in place. If you would like to learn more about the Agile methodology, there is a link to an additional reading at the end of this lesson. Testing and having some level of automation on every task introduced allows the team to be more efficient. It also ensures more confidence that any new feature being introduced will not break any existing flows. You now know what version control is all about. Great work! Now that you have a better understanding of the goals and benefits of version control, you are ready to learn how to start using it.
An interesting fact about collaborating on projects at Meta is that engineers drive every project at Meta. They're in charge of coordinating with product, data scientists, researchers on what we're building and the timelines for that, whereas in other companies, product managers or leadership is often in charge of each project. I'm Layla Rizvi. I'm a backend software engineer on Instagram Calling in San Francisco. In this video, I hope you learn that effective collaboration is important for engineer success at Meta, and learning how to use version control at Meta is also very important. As a backend engineer on Instagram Calling, for my role, I collaborate with other mobile engineers in my department on a daily basis so that we build the best products together. I also collaborate with Instagram messaging a lot because calling and messaging are closely tied. I also work with non-engineers like product and data scientists regularly as well. To collaborate effectively with my coworkers, we message each other on chat to unblock one another, but when something warrants a meeting, we'll schedule a meeting. When something warrants a document, we collaborate together on a document with comments and leave notes for one another. Version control for Instagram is interesting because we have one giant monolithic repository for all of our code for backend. That means that whenever I'm making a change, the code that I'm writing in is shared with every other Instagram team. It is risky in some ways, but it's also nice in others, so I can reuse their code. The other thing that's interesting about version control at Meta is that any engineer can approve any change. At Meta, they're big on this saying that nothing at Meta is someone else's problem. So that means that any engineer can actually work on any change that they want to work on. Version control at Meta is a little different than version control at a lot of other places. While Meta has a giant monolithic repository for our code where we continuously release our code, many other companies have smaller repositories called microservices for each team. So each team has their own code base and only they work in it. They use branches so that they can take their code and merge it back with like the master branch for their team or product. This is great for smaller teams in some ways, but it has its cons in that you might run into a lot of merge conflicts. At Meta, because we have so many engineers, there would be too many merge conflicts if we had branches for each team in the company. Some collaboration challenges for version control on my team is that because we use a monolithic repository, merge conflicts happen a lot. So we try to write smaller changes so that we can easily revert them. We also try to add a lot of gatekeepers so that if we ship something to production on Instagram, we can easily turn it off without waiting for any rollback. We also share our code with Messenger calling. So we also have to add a lot of tests so Messenger doesn't break us. Git blame is a way for us to look at the revision history for files. It helps us so that if I'm looking at a line of code and I don't understand it, I can figure out who wrote that code and reach out to them. I can also figure out what they were trying to do in that code. They write a message saying what the change was for. It's also great so that I can figure out what change to revert if I'm trying to revert a change. I use it every single day. When I need to understand what some code is doing, I'll reach out to the point of contact that wrote that code, which is especially helpful at Meta where there's so many engineers. I often don't know the person I need to get a hold of, so seeing their code helps. In this video, I hope you learn that learning how to work together effectively and collaborating well as learning how to use version control effectively is critical for success at Meta. Getting a diverse set of perspectives on what features you should build, who you should build for, what a feature might need or how it can improve is really helpful. And the rewarding part is that your end result, your project ends up being better.
As a developer working in a team, you are continually writing, changing, or updating existing source code. It may happen that while you are working on a new feature, another developer in the team is busy fixing an unrelated bug. With multiple developers all working in the same code base, keeping track of all of those additional updates can be problematic. Luckily, version control addresses these kinds of problems. In this video, you will discover the different types of version control systems, learn how they operate, and learn about their similarities and differences. There are many different version control systems available. For example, Subversion, Perforce, AWS Code Commit, Mercurial, and Git, to name a few. Version control systems can be split into two types or categories: centralized version control systems and distributed version control systems. Both types are quite similar, but they also have some key differences which set them apart from each other. Let's start with centralized version control systems. Centralized version control systems, or CVCS for short, contain a server and a client. The server contains the main repository that houses the full history of versions of the code base. Developers working on projects using a centralized system need to pull down the code from the server to their local machine. This gives the user their own working copy of the code base. The server holds the full history of changes. The client has the latest code, but every operation needs to have a connection to the server itself. In a centralized version control system, the server is the central copy of the project. After making changes to the code, the developer needs to push the changes to the central server so that other developers can see them. This essentially means that viewing the history of changes requires that you are connected to the server in order to retrieve and view them. Now let's discover how distributed version control systems work. Distributed version control systems, or DVCS for short, are similar to the centralized model. You still need to pull code down from the server to view the latest changes. The key difference is that every user is essentially a server and not a client. This means that every time you pull down code from the distributed model, you have the entire history of changes on your local system. Now that you know a little about CVCS and DVCS, let's explore some of the advantages and disadvantages of each. The advantage of CVCS is that they're considered easier to learn than their distributed counterparts. They also give more access controls to users. The disadvantage is that they can be slower, given that you need to establish a connection to the server to perform any actions. With DVCS, you don't need to be connected to the server to add your changes or view a file's history. It works as if you are actually connected to the server directly, but on your own local machine. You only ever need to connect to the server to pull down the latest changes or to push your own changes. It essentially allows users to work in an offline state. Speed and performance are also better than its CVCS counterpart. DVCS is a key factor in improving developer operations and the software development lifecycle. You will learn more about DVCS later in this course. And there you have it. You can now differentiate between a centralized and a distributed version control system. You also learned how they operate and what their benefits are. As an aspiring developer, I'm sure you can appreciate the importance of version control systems. Well done. I'd like you to think back to a time when you thought you'd lost work because it had been overwritten or deleted. As you have previously learned, version control and version control systems help developers keep track of their code and up to date with any changes. In this video, you'll get a feel for how developers use version control to keep track of changes and resolve coding conflicts. When working with a team of developers, it's essential for the code base to have a source of truth that has all historical changes. Version control systems play an integral part in aiding this process by providing a full history of changes of every single file added to its repository. It makes collaboration across a team easier and also aids in working toward a common goal. Whether it is adding new features and following the flow of how they were implemented, or discovering where a potential issue may have been introduced, being able to accurately pinpoint the who, the when, and the what of those changes is paramount. The revision history will record the essential data points so any developer or team member can walk through the entire project from start to its current state. Every change that has occurred on the project should be easily accessible, either by a simple command or integration into the developer's IDE. It's important for organizations to define standards for how developers communicate changes they make. Developers need to know prior to looking at the code what the lead developer's aims are. The more information, the better, and this creates a stronger team environment that is more transparent and open. Now I will guide you through an example of a typical development team working on an e-commerce application. Suppose you're working in a team with 3 other developers to release a new feature. You've been tasked with creating a new feature to enable experiments on the website. This will allow the marketing department to test user behavior. A daily report is generated that ranks the effectiveness of each experiment. The reports will give insights into how each experiment is doing. They will then provide the results of which experiment is the most successful and overall winner. After all the code changes, the developer will push their changes to the repository and create something called a pull request. Developers will then peer review the pull request to approve, request changes, or decline. When working on a single project, there's usually some level of crossover between the developers. When this does occur, the history of revisions can help aid the developers in seeing the full life cycle of changes that have occurred. It is also essential for merging conflicts where multiple developers have made changes that may need to be resolved prior to the code being approved. The history will show who made the change, for what reason, the code itself and its changes, and the date and time of when they occurred. Typically, on a new project, you will encounter changes in one task that may cause potential issues or conflicts with another. The history of revisions will give the team the ability to manage and merge these changes and deliver the business objectives in a timely manner. Well done! You've now learned about the history of revisions. Remember, it's vital to have a system in place to keep a record of all changes to the code base. This is critical when working with a team of other developers. You should now be able to describe how developers use version control to fix any conflicts that may occur during production. Well done! You've reached the end of this introductory module on software collaboration. It's now time to review what you've learned during these lessons. This module started with a case study about how software engineers collaborate across the globe without wrecking one another's code. You then began to explore the answer to the question, what is version control? You learned to describe how modern software teams collaborate and work on the same code base, list different version control systems, explain different version control methodologies, and explored software development workflows. You learned about the history of version control and that it has been in use before the internet was widely adopted. You explored conflict resolution and discovered the important role of version control in the software development process. You learned about some of the common tools and strategies developers use to implement version control, such as workflow, continuous integration, continuous delivery, and continuous deployment. The differences between staging and production were explored, and you learned that the staging environment should mimic your production environment. You also learned the many areas that benefit from creating a staging environment, including new features, testing, migrations, and configuration changes. You learned that any issues should be caught and fixed in the staging environment before going live in production. You have also explored downtime, vulnerabilities, and reputation regarding production. You should now be familiar with version control. Well done! You're making good progress on your learning journey. One of the first things you learn to do when you use a computer for the first time is to operate the mouse and type on the keyboard. At first, it goes slow, but as you become more competent, you interact with your computer and it responds as you want it to. But what does it really mean to interact with your computer? In the context of using a computer, the term interact simply means to exchange information, or even simpler, send and receive information. So essentially, a computer is sending data to you, and you receive it. In turn, you also send some data to your computer, and the computer receives it. I've talked about the mouse and the keyboard, but can you think of other ways in which you and your computer interact? Computers have various input and output devices. The input devices include a keyboard, mouse, microphone, camera, touch-sensitive devices, and so on. The output devices are things like speakers, monitors, headsets, and haptic devices, to name just a few. You use all these devices to send data to a computer and receive data from it. But there's something else that supports communication with your devices. These are graphical user interfaces, or GUIs, which facilitate your interactions. GUIs are popular because they require very little training to use. GUIs offer an easy way to interact with devices, but they also somewhat limit the scope of human-computer interaction. As an alternative to GUIs and input devices, such as microphones, you will learn to interact with your computer through the command line. The command line is a very powerful alternative because it allows developers to perform tasks quicker and with enough experience, less potential for errors. To use this powerful tool effectively, you need to have a certain level of knowledge. You might feel that the learning curve for the command line is a bit steep, but take it from me, the payoff is definitely worth it. By learning just a few commands, you can perform various tasks, such as creating new directories, creating new files, combining directories, copying and moving files around different directories, and searching through files using various criteria and keywords. As you become more advanced in using the command line, you will be able to perform tasks such as track software, access and control remote servers, search for files using specific criteria, unzip archives, access software manuals and display them in the command line, install, upgrade, and uninstall software, and mount and unmount computer drives or check disk space, and so on. Pretty advanced stuff, don't you think? But the list goes on. You can write scripts to automate various tasks, control user access to files and programs, stop, start, and restart programs, create aliases of only a few characters long to initiate very long commands, download files from the internet, run various software, and finally, run and control self-contained virtual software, which is also known as containerization. There are many, many ways to use the command line, but for now, I will guide you through some basic commands to get you started. First, the cd command, which stands for change directory. This is used to point our command line to a specific directory, for instance, a certain folder. For example, on Linux, if I type cd:// and desktop, I will point the command line to the desktop of my computer. When you type cd:// you will move out of the current directory and back into the parent directory. Next is the touch command, which makes a new file of whatever type you specify. For example, To build a brand new file, you can run touch followed by the new file's name, for instance, example.txt. Note that the newly created file will be empty. You can also make new folders using the mkdir command. For example, mkdir followed by the title you want to give the new folder. To view a history of the most recently typed commands, you can use the history command. There are many other commands that you can use, but with the ones I just introduced, you can already do quite a lot. I'll take you through a quick scenario as an example. Let's say you want to point the command line to the desktop directory, and then add a new folder there titled My.js project. Next, you want to point the command line to the My.js project directory, and make a new file which you will call example.js. And finally, you want to open the example.js file in VS Code. To do all of this, you will need to run the following commands. The first action you'll do is to use the change directory or cd command. Then you want to use the mkdir command to make the new folder. To move into the new folder directory, you use the cd command again. And then you use the touch command to create the file. The final command is the code command, which will open the file in VS Code. If you've run all these commands correctly, you'll end up with a My.js project directory on the desktop with the example.js file inside of it, and additionally, that example.js file open inside VS Code, ready to be edited. In this video, you discovered that you can interact with computers on a more advanced level through the command line. You now have a better idea of what kind of advanced tasks the command line allows you to do. And you are also ready to try out a few basic commands. I encourage you to start practicing some of these commands. Just like you got better and better at typing and moving the cursor with your mouse, I assure you that with practice, you will soon use command line like a pro. I'm pretty sure you use your phone to perform a number of activities, such as sending messages, shopping online, and watching videos. You simply tap your screen, scroll, and swipe. But have you ever thought of how your phone responds to your tapping, scrolling, and swiping? You interact with your phone and computer through a graphic user interface, or GUI, which is just a layer above underlying commands that tells the device what to do. Developers, however, need to know how to use specific commands to perform various types of tasks. For example, to create a new folder on the desktop, you right-click and choose New Folder. In the command line, you use the specific command mkdir to achieve the same result. Having a grip on Unix commands specifically is a great skill to have in today's software development world. In this video, you will get started with a few basic Unix commands. Did you know that the majority of companies run their platforms on the cloud, and 90% of these systems run on a platform called Linux? You might be wondering why I am discussing Linux while the topic of this video is Unix commands. To answer this, let's explore some history. Unix preceded Linux and was developed by Ken Thompson and Dennis Ritchie and team at AT&T Labs in 1969. Linux came much later on and was originally developed as a hobby by Linus Torvalds, hence the name Linux. The commands that you will explore in this video originated from the Unix platform, but you can use them in most modern environments that run some flavor of Linux. Using the command line could seem a little intimidating at first, but you will quickly learn that Unix commands are simply a layer below the normal actions, such as opening file directories or renaming files. Windows, for example, became the dominant desktop operating system mainly due to its easy-to-use GUI. Windows allowed non-technical users to perform tasks without having to learn a list of commands. But you, as an aspiring developer, will learn to perform tasks using Unix commands. Before I delve into some of the most common commands, it's important to note that each command has a set of helper instructions. These helpers give detailed information about how the commands can be run and how something we call flags can be passed. One of these helpers is the man command. Man is short for manual, and when called against a command, it will display a detailed manual of instructions for that given command. For example, the command man --ls will show you the detailed manual of instructions for the list command ls. You can also use something called flags in conjunction with Unix commands. Flags are used to modify the behavior of a command. Think of them as options that can either change or extend the functionality of the given command. Next, you will learn about some of the most commonly used Unix commands, and in the next video, you will see some of them in action. The cd, or change directory command, is used to move from different directories of the file system. You can learn more about working with relative and absolute paths from the additional reading at the end of this lesson. ls is used to show the contents of the current working directory. The ls command can accept many different types of flags that will change what is returned in the response. For example, ls-l lists the file out in list order and shows the read or write permissions, owners, and groups it belongs to. ls-a, on the other hand, will list all files and directories, including hidden ones. The pwd, or print working directory command, shows the full path of the current working directory. The copy, or cp command, copies files or folders from one destination to another. And the mv, move command, moves files from one directory to another. In this video, you learned about some of the most commonly used Unix commands. Next time you use your device, think about what commands run underneath the GUI to complete the tasks you are performing. Okay, so I've opened up my terminal window. Let's navigate to my home directory. I type the cd command and then a tilde, followed by the enter key. Then I use the ls-la command to return all of the files in a list, including all hidden files. Notice two files, a bashrc file and a bash profile file. For now, I want you to focus on the bashrc file first. I can use the command ls.bashrc to check this file. The bashrc file is mainly for configurations. It is essentially a script file that's executed when you first open the terminal window. What's in there will be configurations for the shell itself. For example, the types of colors that I'm using. I can also add in things around my shell history, like how much history of previous commands I want to store and so on. So any configuration options that I put in here will be executed when the terminal session begins. I press the Q key to exit the less environment. The other file is the bash profile file. So I can run the less command again, this time with .profile. This tends to be used more for environment variables. For example, I can use it for setting environment variables for my Java home directory, or my Python home directory, or whatever is needed during development. Again, I press the Q key to exit. Now I will create a simple shell script. For this example, I will use Vim, which is an editor that I can use which accepts input. So type vim, and then I create a new file by typing the testshell.sh and press the enter key. And then at the top of the file, I put in what type of file I want it to be. In this case, it's going to be a bash file. If I press the I key on my keyboard, it'll set insert mode. Then I put in a hash symbol, followed by an exclamation mark, a /, the word bin, another /, and then the word bash. This lets the operating system know that this is a bash script. The script is very simple. I want to print out some type of text onto the screen. So I use the echo command and type in what I want to print out. In this case, hello world. Press escape to get out of insert mode. Then I type :WQ! To save the file. Press enter, and if I look in the directories now, notice there's now a file named testshell.sh. The other thing to notice is that this file can't be run at the moment. In other words, it's not executable. It's just a read-write file, but I want it to be executable, which requires that I have an X being set on it. In order to do that, I have to use another command, which is called chmod. After using this command, I type in the type of permissions that I want. So I type in 755. And then I want to set the file that I want to add the permissions to, which is testshell.sh. And if I use the ls-la command again, I notice that the file has now been turned into an executable file. This means that I can now run the file from the command line. To run the file, I press /testshell.sh followed by the Enter key. And now you notice the words Hello World are printed out on the screen. This is how you can create simple scripts and make them executable within the Bash shell. I've opened up the command line, and first I want to check what directory I'm currently in. To do that, I run the pwd command. Pwd is short for print working directory. I type pwd and press the Enter key. The command returns a /, which indicates that I'm currently in the root directory. This is the top-level directory within the operating system. If I want to check the contents of the root directory, I run another command called ls, which is short for list. I type ls and press the Enter key, and now notice I get a list of different names of directories within the root level. In order to get more detail of what each of the different directories represents, I can use something called a flag. Flags are used to set options to the commands you run. Use the list command with a flag called L, which means the format should be printed out in a list format. I type ls --l, press Enter, and this returns the results in a list structure. Let's focus on some items in this list. First, you need to know what's the difference between the link file, a directory, and a standard file. The link file is always represented by the L, and it's always going to be at the very start of the output. The temp directory has an arrow beside it, which points to tmp. This means temp is the same link to the actual directory tmp. The next item is the bin directory, and it's represented as a D. That means that's just the standard directory, and that you can use the change directory command to actually open the directory and check its contents. Now, let's focus on the etc directory. To change directory, use the cd command. I type cd etc to change to the etc directory and press Enter. Now, I type ls to check the contents. Notice that the contents are completely different from the root. The command returns what's inside the etc directory. To verify that you're in the etc directory, run the pwd command, and it confirms that you are in etc. Again, if I want to change the output, type ls-l, and it returns a printed list format in list structure. Let's cover a standard file, like a text file or a configuration file. The association or the symbol for it is the hyphen. In this case, it represents the file resolve.conf. Understanding the different symbols and different name conventions is important when you're trying to find specific files. Notice that there is a root, and that these just represent the owner and the group that it's associated to. So if I want to move back from the etc directory, there are two ways to do it. One is by typing in cd ... which means that I go back up to the parent directory. Press Enter, and then I type pwd. Notice I am now back in the root directory. To step back into etc, type cd etc. To confirm that I'm back there, type pwd and Enter. If I want to use the other alternative, you can do an absolute path. Type in cd / and press Enter. Then I type pwd and press Enter. You can verify that I am back at the root again. To step through multiple directories, use the same process. Type cd etc and press Enter. Check the contents of the files by typing ls and pressing Enter. Let's try another directory, for example, the ssh directory. Type cd ssh and press Enter. Then type ls and press Enter. Again, you'll notice the different output from each one. To move back up to the previous directory, I can use the cd ... and I should now be in the etc directory. And then again, back to the root using cd ... which will take you back to the root itself. Finally, I can confirm that I am in the root by typing the pwd command and pressing Enter. You have now learned how to navigate and change directories. So first, I want to check what current directory I'm in by using the pwd command and pressing the Enter key. You can see that I'm in the root directory, which displays as /root. If I type in the ls-l command, notice that I have one directory in here called projects. Now, I will create a new directory called submissions. I do this by typing mkdir, which stands for make directory, and then the word submissions. This is the name of the directory I want to create, and then I hit the Enter key. I then type in ls-l for list so that I can see the list structure. And now notice that a new directory called submissions has been created. I can then go into this directory using the change directory command. I do this by typing cd submissions and then press the Enter key. I type the ls command and notice that there is nothing in there. If I want to add some text files or some content, I can use another command called touch. I type touch test1.txt followed by the Enter key. To add another text file, I type in touch test2.txt followed by the Enter key again. Now I run the ls-l command and notice that the two text files are listed inside the submissions folder. After this, I want to go back to the root level directory, and I do this by typing in cd ... followed by the Enter key. And then I run the ls-l command again, and notice two directories are now listed, projects and submissions. Now I want to create another directory called archive. To do this, type mkdir followed by the word archive, and then hit the Enter key. To see all of the directories, enter the ls-l command followed by the Enter key again. Once again, notice that three directories are now listed: archive, projects, and submissions. To get back to the top view of my terminal, I can clear my screen by typing clear followed by the Enter key. After this, I type in the ls-l command, and now I can see all three directories. Okay, so let's say I want to move the submissions folder into the archive folder. This requires a different command called move, written as mv. In this example, I need to specify the directory I want to move and then where to move it to. So I type in mv submissions followed by the word archive, and then I hit the Enter key. Then I can check to see if the move happened by using the ls-l command, and now notice that the submissions directory is gone. So now I want to go to the archive directory by typing cd archive. Again, I use the ls-l command, and now notice that the submissions directory is listed inside of the archive directory. Recall that I created two text files inside the submissions directory? Well, you'll notice that they were also moved to the archive directory. So I go to the submissions directory by typing cd submissions, which changes the directory. I use the ls-l command followed by the Enter key. And now you can see the two text files are present and they were moved too. You have now learned how to make directories and files and move directories and files. Okay. So I have launched my terminal and I'm running the ls command. It informs me that I have two folders, archive and projects. Next, I can change directory into archive using the cd command and search inside using ls. This reveals a submissions folder. I can then type the cd submissions command to enter into the submissions folder and check what's inside. The ls command reveals two files, file1.txt and file2.txt. Each of these files have some content in them. I can check the content of a file by running another command called cat. I run the command cat file1.txt. This returns the contents of the file, which is some simple text. Another command is the word count command, which is abbreviated as wc. To use this command, I can just call it against the file by typing wc file1.txt-w. The W flag tells the wc command to return the word count. The output informs me that there are 181 words in the file. Let's run another example with pipes. Pipes allow you to pass the output from one command as the input to another. I can perform an ls command on the current directory. Note that this outputs two file names. Let's type the ls command again. Then I pass in my pipe using the vertical line character. Then I use the wc command with the -w flag. Notice that it returns a result of 2 because there's two files in the system. So, what if I want to find the word count of a file using pipes? I just changed the ls command to catfile1.txt pipe wc-w. This returns a word count of 181 for file1.txt. Did you know that you can also combine this command against the directory or multiple files? For example, I can use the command to get a combined word count for file 1 and file 2. To get this data, I just input the command catfile1.txt and then also pass in file2.txt. Then I use a pipe followed by a wc-w. This returns a total word count of 362 for the two files. In this video, you will learn about redirection and the different types of redirection you can use. The basic workflow of any Linux command is that it takes an input and gives an output. The standard input device is the keyboard. The standard output device is the screen. With redirection, you can change the standard input and/or output. There are three types of I/O or input-output redirections: standard input, standard output, and standard error. The shell keeps a reference of standard input, output, and error by a numbering system. The 0 is for standard input, 1 is for standard output, and 2 is for standard error. Now you will learn about each of these redirection types. Let's start with standard input. Taking input normally refers to a user typing information from the keyboard. We use the less than sign for user input. The cat command can be used to record user input and save it to a file. How do we take input and store it in a file such as a .txt file? Let me explain how you can do this by using an example to store user input to a text file. So I have just launched my terminal. But how do we take input and store it in a file such as a .txt file? One of the commands you learn to use frequently in this course is the cat command. This command is actually set up to take in input. On my terminal, I type the cat command followed by a greater than sign, and then follow it by the name of the input file. In this scenario, input.txt. Press enter. Now I can add text to the text file created. At the end of the text, press enter. Next, press Ctrl D to tell the cat command that's the end of the file. To output the contents of the file, enter cat followed by a less than sign, followed by input.txt. Press enter. Notice that the text that I added from the keyboard displays. Let's discuss standard output now. A lot of the commands we have already used, for example ls, send their output to a special file called the standard output. Output direction is handled with a greater than sign. I/O allows us to use redirection to control where the output goes. Now I will demonstrate how you can send output to a text file. Everything in Unix, Linux is a file. This means every time you run a command like ls and press enter, it sends the output of the file to an std-out file. In Linux, if you want to control where the output goes, you can use a redirection. How do we do that? Enter the ls command, enter -l to print it as a list. Instead of pressing enter, add a greater than sign redirection. Now we have to tell it where we want the data to go. In this scenario, I choose an output.txt file. The output.txt file has not been created yet, but it will be created based on the command I've set here with a redirection flag. Press enter, type ls, then press enter again to display the directory. the output file displays. To view the content of that file, use the last command followed by output.txt and press enter. The content that displays using the ls-l directory includes the different files available. Errors occur when things go wrong. When using redirection, you also have to specify that the error should be written to a file. You can do that by explicitly setting the number 2 before the output arrow. And you can also combine it with the standard output of 2 greater than %1 to print both the standard output and error if any occurs. You have already learned that input is represented by 0 according to the shell. Output is represented by 1. The input stream uses the less than sign. The output stream uses the greater than sign. And the error stream uses 2 followed by the greater than sign. It may happen that an error occurs when you are outputting data to a text file. Remember that the error will not correspond with the output stream. It will change to use the error stream, which is represented by 2. Let me now demonstrate how this works. So I have the terminal open, and I'm running a similar example to the standard output. Type the ls command. Follow this by -l to try and print it as a list. Instead of using a directory that we know exists, I'm going to use one that doesn't exist. Enter /bin/usr. Now type a greater than sign followed by the name of the output file. In this scenario, type error.txt. Press enter. Notice that the message cannot access. It states that there is no such file or directory. Normally, you think that it would still print the contents of the file, but because an error occurred, it prints it to the console. There are 2 ways to send the contents to the error.txt file. I type ls-l/bin/usr, then add the number 2, which represents the error output, followed by the greater than sign. Now enter the name of the output file, error.txt. Press enter. To see what we have inside the error file, type less followed by the file name. In this case, error.txt. Press enter. The error message ls cannot access /bin/ no such file or directory displays. If you want to handle both cases where it may find data or may not find data, you can pass in a different redirection. So it handles each one both for output and for error. To do this, again, enter ls-l/bin/usr. Next, add the greater than sign for output, followed by the file name, err_output.txt. This time, we're going to use another redirection to signify that we also want to get errors. To do this, I enter a 2 followed by a greater than sign. This is followed by an ampersand sign and the number 1 to get the output that is available. Press enter. To have a look inside the error file, type /error_output.txt and press enter. Notice that the errors contained inside the error.output file displays. And that brings us to the end of this video. Now you know what redirection is and how to use the 3 types of input-output redirections. Well done. grep stands for Global Regular Expression Print, and it's used for searching across files and folders as well as the contents of files. On my local machine, I enter the command ls-l and see that there's a file called names.txt. If I access that file using the less command, it displays a list of first names in non-sequential order, as in not arranged alphabetically. So what I'll do first is use grep to find some patterns of names that start with similar matches. Then I'll also show how grep can be passed with different flags to get different results. First, I'll perform a standard search using grep. So what I'm going to do is look for names that begin with Sam by entering the command grep samnames.txt. This then returns a list of names that begin with Sam. Keep in mind that grep is case sensitive, which means if I run the same query with a lowercase s, it returns a completely different set of results. Because this query doesn't match the capital S, it returns partial matches in which Sam appears in the middle or end of a name rather than the beginning. Fortunately, I can pass in a flag to ignore case sensitivity. I can do this with the command grep -I, followed by the keyword Sam, and then the file name names.txt again. This time, I get back both users that begin with Sam and also with Sam as a partial match in the middle or the end of the name. So the result set changes based on the type of query that I pass through with different flags. We can also do an exact match by passing in a different flag, and that's the -W, which means it'll match exactly what I'm looking for. So I'll input grep-W and then pass in the keyword Sam with a capital S, and finally our file name names.txt. In this case, we only get back a single result with the name Sam, as any partial matches are ignored. Lastly, I can use a pipe command to combine different searches for grep itself. For example, let's say I want to search across a list of directories for certain executable files. I can combine that with different commands and search across the file structure to find exactly what I'm looking for. If I check all the executable files inside the bin directory by running ls/bin, it returns a long list of results. In order to filter that down, I can run the same query of ls/bin, but this time I'm going to pipe it. Pass in a grep and then enter the keyword zip. You'll find that in this case, I get a much smaller subset back in the results. And if I need to refine it further, then I can also apply the different flags to look for an exact match, a partial match, or ignore case sensitivity. Great work! You've reached the end of this module on the command line. It's now time to review what you've learned during these lessons. In this module, you learned how to use the command line to execute commands in Linux. You were introduced to some of the most commonly used commands that traverse, create, rename, and delete files on your hard drive. You learned how to use piping and redirection to create powerful workflows that automate your work. Having completed this module, you should be able to describe what the command line is and how it is used, explore your hard drive using the command line, create, rename, and delete files and folders on your hard drive using Unix commands, and use pipes and redirection. This module began with a video exploring the answer to the question, what are Unix commands? You learned how to determine the current working directory using the pwd command. You also explored how to create and change directories and files using the command line. You can now create a working directory, create two different directories, dir1 and dir2. Create files and directories inside dir1 and dir2. You can now also use grep to search for files, folders, and contents of files. You're now familiar with the command line. Well done. You're making good progress on your learning journey. Are you familiar with version control or version control systems? Here's a quick example of where they're useful. Have you ever opened an app on your phone and received a prompt to update to a new version? These prompts most likely direct you towards an app store, where you then download the latest version. As you download the new version, you might notice a new layout, button, or piece of functionality. In software and web development, developers use version control to track the differences between versions. And a popular method of tracking versions is the use of version control technologies like Git and GitHub. In this video, you'll discover the answer to the question, what is Git and GitHub? You will learn about the differences between Git and GitHub and how web developers make use of them, and explore the benefits and advantages of both services. Let's start off with Git. Git is a version control system designed to help users keep track of changes to files within their projects. Git was designed to address the challenges that its creator, Linus Torvalds, was having managing the development of the Linux kernel, the operating system for Linux. Linux has thousands of contributors who commit changes and updates daily. Git was designed to help with the challenge of tracking all these changes and updates. As well as helping to keep track of changes, Git was also designed to tackle some of the shortcomings of other version control systems. The benefits that Git offers over similar systems include better speed and performance, reliability, free and open source access, and an accessible syntax. It's also important to note that Git is used predominantly via the command line. Developers tend to find Git syntax and commands easy to learn. The other service commonly used by developers is GitHub. GitHub is a cloud-based hosting service that lets you manage Git repositories from a user interface. A Git repository is used to track all changes to files in a specific folder and keep a history of all those changes. It incorporates Git version control features and extends these by providing its own features on top. Some of the most common of these features include access control, pull requests, and automation. You will learn more about these later in this course. The features are split out into different pricing models to suit different size teams and organizations. It's also important to point out that GitHub is very popular among web developers. It's like a social network. For example, projects can be private or public. Users on GitHub have their own profile, which other users can follow. Public projects can accept code contributions from anyone across the globe. And it also includes multiple features outside of its core development tools, like documentation, ticketing, and project features. You're now familiar with Git and GitHub version control systems, along with the benefits and advantages that they offer. This is just the beginning of your version control journey with Git and GitHub. Great work. Okay, so I have just logged into the GitHub website. Once there, I click on the green button with the text Create Repository. When I click on the button, I am redirected to the Create a New Repository screen, where I'll be prompted for who the owner is. I choose my account as the owner option for this example. Next, I need to input a repository name. So I type a name called my-first-repo. Notice that the input field has a green tick icon beside it. This is just GitHub letting me know that this name is available to create the repository. If it's not, I will see an X icon and be prompted to rename it. Okay, so now I need to type a value for the description input. For this, I type practice account for learning Git. The next option I want you to know about is if you want the repository to be public or private. Public just means that anyone on the internet can see the repository. I still have control over who can make changes to it. It's just available on the viewable aspect of it on the internet. The next option is private, meaning it's not available for anyone to see. I can only allow access by granting people access to the repository. The next few options are about initialization. I can initialize a repository with a README file, a git-ignore file, and a license if one is required. For now, I'm just going to choose the README file option and then click the Create Repository button. Okay, so a repo has now been set up, and I can see that I have one single file in the repository called readme.md. MD is just short for Markdown, a popular method for creating documentation because it's shorthand for creating HTML pages. This allows me to do things like creating titles and texts. I can insert images and various other web page elements. Notice that the main branch has also been created, and it's important to know that every repository you create will have a single main branch at the start. This is also known as the main line. Next, I'm presented with additional button options. The first is labeled Go to File. Then there is Add File, which you can use to add a new file from the UI. And finally, a green button labeled Code. Clicking this button provides me with the GitHub UI options for cloning down the repository. First is the option for HTTPS, which contains the HTTPS URL of the repository. And I can use this to pull it down by using the git clone command. Next, there is an option for SSH. But to use that, I have to set up my SSH keys and assign them to the user accounts. And finally, I have the GitHub CLI option. Underneath, notice that there are additional options for GitHub Desktop if I would like to use that. And finally, I can also download a compressed zip file containing all the files and folder structures. For this demo, I will show you how to use HTTPS. To begin, select the HTTPS option and click on the copy button to copy the HTTPS URL for cloning. Now I go to my command line that I will be using to run the commands to clone the repository. I'm currently in my home directory. Okay, so what I usually like to do is create a directory for all repositories that I'm working on at the moment. First, I create a directory using the command make-dir. Then I type the name of the directory I want to create, which is projects. Next, I can cd into that, and now I can run the commands to clone the project from the GitHub UI. To do this, I type the command git clone and paste the HTTPS URL I copied earlier. Finally, I press enter on my keyboard. Notice that I receive a message stating that Git is cloning into the My First Repo folder. It then displays messages about all the objects that have been received. It also displays a 100% status message and then finally a statement that simply says done. Now I can list the directory by running the ls-la command, which means list all directories. Notice that I have my repository, which I named My First Repo. This is the name of the repository that we set up on GitHub. Finally, if I enter inside that folder using the cd command, I can see a single file, the readme.md file. If I use the ls-la command, another file is listed, which is just named .git. You will learn more about this later when you explore how to use this for source control. As you now know, GitHub is a cloud-based hosting service that lets you manage Git repositories from a user interface. It's like a social network. You can follow users or accept code contributions from anywhere in the world. In a previous video, you created and cloned a repository to your local device. I am now going to explain to you how to pull the repository to your local device. I will be demonstrating commands that you can use in Git Bash Shell for Windows users and Terminal for Mac users. This refers to the application where the commands are typed in. Let's move to the directory I want by typing cd and the name of the directory, My First Repo. Once inside the directory, run the list all command by typing ls -la. -la is short for list all. There are 4 items in this directory. I will focus on 2 of them, the .git item and the readme.md item. Let's start with the readme.md file. This item was added when I created the repository on GitHub. The other item is a folder called .git, which is a hidden folder used to track all the changes. In Linux, any folder starting with a dot is a hidden folder. This folder is automatically created when you create a repository, and you will learn more about it later in this course. In the command I ran, I added the switch -la so we would list all files and folders, including the hidden ones. The .git folder is initialized by running the git init command. As the repository was created on GitHub, it was not required for us to run it. GitHub handled all of this as part of its create new repo flow. Now, let's focus on Git workflow. Git uses workflows which can be broken into 3 states, namely modified, staged, and committed. Now, I will go over each state and then provide an example of adding a new file to my Git repository to show it in action. Let's start with the first state. Adding, removing, and updating any file inside the repository is considered a modified state. Git knows the file has changed, but does not track it. This is where the staging state comes in. Let's turn to it now. In order for Git to track a file, it needs to be put in the staged area. Once added, any modifications are tracked, which offers a security blanket prior to committing the changes. Then, the last state is the committed state. Committing a file in Git is like a save point in many ways. Git will save the file and have a snapshot of the current changes. Let me introduce you to an example that summarizes the workflow clearly. Suppose you have a workflow that contains the 3 stages just mentioned, as well as the remote repository. A file is added from the working directory to the staging area. From there, the file is committed and then pushed to the remote repository. From the remote repository, the file can now be fetched and checked out or merged to a working directory. You will learn more about this later. Well done! You've covered some of the Git fundamentals and now know what is inside a Git folder and understand the Git workflow. So, I've opened up my terminal window. I'll have a look at what directory I'm currently located in. I can do this by running the pwd command, which is short for print working directory. Notice that I'm in the directory my first repo. Now I can check inside that directory by running the ls-la command. I can see that I have two items, a readme.md file and a hidden folder called .git. Before I add any files or make any changes, it's always good practice to check if any changes or commits are currently there. I can do this by using the git status command. Git status also displays what branch I'm on. In this instance, I'm prompted that I'm on the branch called main, and that my branch is up to date with the origin main. This means that all the latest files on my local machine are exactly the same as what is displayed on the GitHub UI, which represents the server that everyone commits to. Git status also tells me that I have nothing to commit and that my working tree is clean. Now, let me show you how to add a simple text file. I'll add a file called test.txt by using the command touch test.txt. Then I'll run the command git status again. Now, Git is telling me that I have an untracked file, which is the test.txt file that I just added. It's also telling me that I have nothing added to the commit, but that untracked files are present, and that I should use git add to track them. The purpose of the git add command is that I'm essentially prompting Git and letting it know that I want to track this file, and that it'll be included as part of my commit. The first phase of this process is just to run the command git add test.txt. Now I'm going to run git status again to check that file is now being tracked. Notice again that I'm notified that my branches are up to date. But it's also telling me now that there are staged changes to be committed, which is this new file called test.txt. It prompts me asking if I want to revert those changes. For this, I can use the git restore command with the flag --stage and the file name test.txt. Running the command will unstage the file from the commit. I then run git status one more time to see the file is back to an untracked status. So once again, I'll add the file using git add test.txt, run git status, and now notice that the file is back in a tracked state. Okay, let me clear my screen before moving on. To do this, I use the clear command. Now any changes that I make from here on will be tracked. And then at the end, I will use the git commit command. The staged area is really important because you're essentially preparing to get all of the files and changes that you want as part of whatever feature you're working on. Basically, you are getting all of that content ready for commit. You also have to remember that this is only on your local machine. The distributed manner of Git means it will only push to the server using the actual push command itself. But any change you make here is only specific to you and your local machine. Anyone else who pulls down the project from GitHub will only get what's available on the remote server. Okay, now I want to explain to you how to run the git commit command. First, type in git commit. You can pass in a flag of -m, which stands for message, allowing you to type in a message which will be attached to the commit. In this example, the message is adding a new file for testing. Next, press return on the keyboard. And now notice that the response states 1 file change, 0 insertions, 0 deletions. There is also a create mode statement with the name of the file, test.txt. Finally, if I run the git status command, the response says that there is nothing to commit and the working tree is clean. However, I want to be aware of the message at the top of my screen. This message tells me to use git push to publish my local commits. And this ties back in with what I mentioned earlier. All of these changes are on my local machine, and they will only be uploaded to the remote server when I run the push command. You'll learn more about the push and pull commands in a future lesson. Okay, I've opened my command line. I should check to ensure that I'm in the correct directory using the pwd command. I can see that I'm in the my first repo directory. Now, it's good practice to perform a git status command to make sure that I have no commits outstanding. If there are no commits and the shell is clear, then my branch will show as up to date with origin main outside of the main branch itself. So my next step would be to create a new branch. To create this new branch, I use the git checkout command by typing git checkout-b. I then call this new branch feature/lesson, which I'll refer to as feature lesson for the purpose of this video. But this is just one way to create a branch. I could also use git branch and pass in the name as well. These methods are the same and can both be used to create a branch. The key difference between them is that git branch just creates a branch, but git checkout-b moves me from the main branch into the branch that I created. I can verify that I've been moved between branches by running the git branch command. This will then tell me if I have switched from the main branch to one of the feature lesson branches. Any changes that I make will now only occur in this new branch. It's important to remember that the main branch has no indication or knowledge of any of these changes, even when I push code to the main repository. This is because that branch exists in isolation. The new branch needs to be merged back into the main branch to recognize changes in the feature lesson branch. This is where it'll come in with a pull request. The purpose of a pull request is to obtain a peer review of changes made to the branch. In other words, to validate that the changes are correct. When coding, many teams will have conditions around the unit tests and integration tests. These conditions will usually include validating that the standards have been met for merging back into the main line. A team will also check for any issues that might have been missed. The next step is to add a file to the new branch. I can create a simple text file called test2.txt using the command touch test2.txt. Then I add it using the git add command. I then commit it using the git commit command. Once I've committed the new file, I need to push my changes up to the remote repository with git push. I type git push-u origin feature lesson. It's good practice to specify -u. This means that I'm only going to get updates from the upstream, which in this case will be the main branch. The result of this is that the origin won't be my main branch anymore. Instead, it's feature lesson. I press the enter key and this pushes the new branch up to the remote repository. As I am using HTTPS, I will be prompted for my login information. Once this action has been completed, GitHub will recognize that a new branch has been added. It will then prompt me to create a pull request that can be compared against another branch, in this case, the main branch. So my next step is to open the GitHub UI. GitHub will show my new branch with a prompt. Click on the Compare and Pull Request button. A pull request lets the team know that I've made new changes that I want them to review, and that I also want to approve or request changes to the actual pull request itself. Another thing to note on the GitHub UI is that I'm comparing this with the main branch. I've essentially cut a branch from the main called feature lesson. I've then added a new file called test2.txt, and it's this file which is the main difference between the two branches. Next, I check the pull request. I can see that there's been one commit. In other words, just one file has been changed, and it's been added as test2.txt. I then click Create Pull Request. The team will then review the changes and either approve or decline them. Once approved, you can then merge your changes to the main branch. This is much cleaner than everyone working off the main branch. It's particularly useful if you have features that are closely tied together. For example, you could be working with a feature that crosses over with some code or requires changes that most likely will be altered by someone else. So, the approach of keeping everything at branch level is much easier than having everyone working from the main line. In fact, everyone working off the same branch is more likely to cause issues. Having independent branches makes the project easier to manage. Also, there's no limit to how many branches you can have. The team decide on the naming conventions that they use. In a lot of cases, when adding a new feature, you can add the keyword feature, then followed by the branch name, like a URL path, such as feature/lesson in this example. For bug fixing, fix/ can be used. So, because we have no reviewers in my current project, I'm just going to merge the branch. Then I'll confirm the merge. Once confirmed, I'm presented with the option to delete the branch. On your own projects, it's up to you whether you want to keep the branches or delete them. For now, I'm going to keep the branch. Then I can return to my code where the test2.txt file has merged into the main branch. I can then confirm that by going back to my command line. Next, I look at Git status again to check if there's something to commit. At this point, there's nothing outstanding. I'm still on the feature lesson branch. I can check out my main branch by typing git checkout main. Then I run the git pull command. I'll then receive the latest changes that were merged in from the feature branch that I just created. Notice that the test2.txt file is now available. I can also verify that by doing a simple check within the directory by using the ls command. This returns a README file, test.txt, and the test2.txt, which is from my branch. You have now learned the branching workflow, which you'll use regularly when collaborating with other developers. In the pre-internet era, saving project files to different machines for backup and transfer was a tedious process. It required manually copying files between machines one at a time, making things slow for teams. Nowadays, the cloud has enabled a more efficient way to do this, and in this video, I'll explain the differences between remote and local on GitHub. You have previously learned about the flows modified, staged, and committed in a Git workflow. Now you will learn about pushing your changes from your local to a remote repository. Remote refers to any other remote repository to which developers can push changes. This can be a centralized repository, such as one provided by GitHub, or repositories on other developer devices. In this lesson, you will be hearing some new terms, such as clone, push, pull, and repo. Don't worry, these will all be explained soon. The remote code is accessed through a URI, which is unique and only accessible to those who have permission. Local, on the other hand, refers to your machine, which can be a laptop, desktop, or even a mobile device, and is only accessible to you. To demonstrate both of these in action, let's say we have a project called Coding Project 1, which is located on GitHub with a unique URL. In other words, this project is stored on the remote server. When a user wants to copy this project to their local device, they need to either perform a clone, if it's the first time, or pull it to get the latest changes. To clone a project, a user must first choose a folder on their local machine. Coding Project 1 is then cloned from the server and copied into the chosen folder. The user can then make changes to the project and push those changes back to the server. Other users working on the code base won't see those changes on their local machines unless they pull the latest changes from the server. One of the advantages of Git is that you can work offline and then commit your changes when you are ready. Now, let's go through an example of how exactly you would do this in GitHub. In this video, I'm going to explain what local and remote mean in GitHub and help you to understand the differences between the two. First off, I'm going to create a new local repository using the git init command. I'll start by inputting mkdir to create a new directory, and then I'll set the name as my second repo. Next, I'll use the change directory command, which is cd, followed by the name that I just set. Finally, I'll perform the git init command to create my new repository. This will return a line telling me that an empty repository has been initialized under root, projects, my second repo. If I execute another command called git remote, it comes back as blank. The reason for that is that I've only initialized a local repository which has no connection to a central repository that sits either on GitHub or another server. Right now, it's only available locally on my machine. Now, I'll step back out from this directory and go into my first repo with a cd command again. This is a repository that I created earlier and does have a connection to GitHub using the remote URI. I'll then check it by using the git remote -v command. Git tells me that it's set to Git Tutorials 101 myfirstrepo.git. Next, I'm going to set this against our second repository. I'll step into the new directory once more using the cd command. In this case, we're going to add this URL to the remote settings by using the command git remote add, specifying a name, and then passing in our URI. The name that is typically used here is origin, so I'll stick with that. So again, the full command with the URL should read git remote add origin git at github.com git tutorials 101 myfirstrepo.git. This time when I execute the git remote -v command, I have this set up against the Git Tutorials 101, which sits up on GitHub. What I'm going to do next is use the git pull command, which will connect with the GitHub server and pull down all the changes from the repository. So on my local, I now have all the changes, but when I check the directory, it's blank. The reason for this is that I haven't set up a branch that matches with what I have on the server repository. Fortunately, I can change that by performing the command git checkout main, which will set up a branch main on my local that tracks the branch main from the remote. And now when I check my folder using the ls command, it confirms that I have the readme, test, and test2 files available on my local. In this video, you learned about the differences between local and remote in GitHub. This will help set you up to exchange data more efficiently within your development team. See you next time. By now, you should know how to use git add and git commit to add new changes to your local repository, put them into the staging area, and get them ready for a commit. Now, let me guide you through the next step and upload these changes to the remote repository using git push. I'll also demonstrate how to retrieve changes from the remote servers and apply them to your local repository with git pull. Before we begin, let's go over the command line and perform the command git status. Git tells me that I'm on the branch main, but also that my branch is ahead of the origin main branch by one commit. What this means is that all the changes that I have on my local repository are currently ahead of what is stored in the remote repository on GitHub. That ties into Git's distributed workflow in which you can work in an offline state and then only ever communicate with a remote repository when you use the commands of git push or git pull. Now I'll guide you on pushing your changes to the remote repository, and then I'll demonstrate how to use the pull command to get the latest changes. It's always good practice to check which branch you're currently on, and you can use git status or git branch to do this. This is important because if you do make changes in a different branch, you need to specify where you're pushing up to. So let's push up the changes using the git push command. I'll specify the origin branch to be the main branch, as in I'm pushing my changes to the origin as the remote repository, and then I want to push it to this branch as the main. I'll be prompted for my login information as I am pushing using HTTPS. Once I enter my login information, you'll notice that the commit is pushed from the local main to the remote main on the remote repository. Let's refresh the page on the GitHub website. You can see that my test.txt file now appears there. That's taken the commit snapshot that I have in my local repository and pushed it up to the remote repository. Git has then compared those files with what's on the remote repository to find any conflicts or problems. If none are found, it'll just merge them straight through, which is classed as an auto merge. If there are any conflicts, my push will fail. Before doing a push, it's also good practice to perform a git pull in order to get the latest changes from the remote repository and reduce the odds of encountering a conflict. Because I only have a single file and this will be a new repository, I'm not going to run into any conflicts or any issues. So now let's move on and I will guide you through how you can use git pull. Normally, when you're working on a project, you could have several developers all submitting with different branches, different code, and different features. In order for you to get those changes, you need to use the git pull command. To demonstrate this, I will add a single line to the test.txt file using the GitHub UI and then add the commit change, updated the test.txt file. I'll then commit it directly to the main branch by clicking on Commit Changes. The changes now appear on the UI, but because I haven't used the git pull command on my local machine yet, I should have no content on the test.txt file. Let's verify by using the cat command on test.txt, and sure enough, the file is empty, which is what you'd expect. As I mentioned before, I need to run the command git pull. This will get the latest changes from the remote repository. If any new changes were added, it'll be reflected in the shell output. I run the command, and in this case, Git tells me that one file has changed with one insertion. If I run the cat command on test.txt once more, it shows that the line "This is my change" is now available in my local directory. With git pull, you're taking all that data from the remote server. Git then merges the snapshot from the remote with the snapshot that's on your local. It will auto-merge them if there's no conflicts. Once that's complete, I'll have the latest changes on my local machine. You have now learned how to push to and pull from your GitHub repository. Have you ever applied for a job? You know the process. Prepare your resume, look for jobs, submit an application, prepare for interviews. That is an example of a workflow. In computer programming, workflows are really important. By the end of this video, you will be able to describe what a workflow is, and you will also be able to identify different workflows available. Now, let's start with an example to illustrate why workflows are important. As a developer working on a project, you first need to pull the project down from a remote repository to your local machine. This is commonly called checking out a project or pulling a project. Once on your local machine, you can build and run the project and make changes. When you are done, you have to push the changes you made back to the remote repository so other developers can see them. From this example, you can understand that the purpose of a workflow is to guide you and other members of your team. It should not disrupt or cause blockers for deployment or testing or for any other developer who contributes to the project itself. Choosing a workflow needs careful consideration. It can depend on the size of the team, the culture of your workplace, and also the type of product you intend to build or update. With that in mind, let me explain feature branching, a common workflow used by many developers. Feature branching means you create a new branch from the main line and work on this dedicated branch until the task is completed. Rules and conditions need to be made in order for this branch of code to be kept in a good state. Every code base has a main repository, which is essentially the source of truth for the application. All changes, such as add, edit, or delete, are submitted directly to the feature branch. The main branch stays as is. When you are ready and happy with the code you have added, you have to commit the changes and then push to the server repository. To commit, you push the changes, and as it's a feature branch, a pull request follows. The pull request is compared to the main branch so developers who peer review the code can see exactly what was changed. Once it's reviewed and approved, it can then be merged into the main line. Now, let me guide you through how this works using Git and GitHub. Before creating a new branch, always ensure you have the latest code. You can do this by running the git pull command to pull the latest code from the remote repository. Next, you need to create your new branch. You can do this by passing the -b flag with the checkout action. Next, let's add new content to this branch. Let's create a readme.md file. To do this, type git add dot or git add readme.md and press enter. Next, you need to commit the new file and provide a meaningful message so other developers can discover what you added. To do that, run the git commit command with the -m option to include a message with a short description of the changes being committed. The file has now been added to the local branch. This means that the file is only visible locally to you. To allow other developers to see the changes, you need to push the file to the remote repository. You can do that by running the git push command and referencing the new file. The changes are not pushed to the remote repository on GitHub. Your next action is to get it reviewed as part of a pull request, but more about that later. And that brings us to the end of this video. Now you know what a workflow is and how a feature workflow works. Well done. Previously, you learned about the hidden folder called .git that is located in each project. You know that this folder is responsible for keeping track of all changes across a project. How does Git know what branch you're currently on? Let me explain. It keeps a special pointer called head, which is one of the files inside the .git folder. This file refers to the current commit you are viewing. You will now learn how to identify the current commit you are working on. First, open the .git folder on your terminal. Type cd.git and press enter. Next, type cat head and press enter. In Git, we only work on a single branch at a time. This file also exists inside the .git folder under the refs/heads path. Let me show you. Type cd.git and press enter. Next, type cat/refs/heads/main. Press enter. After you entered this command, a single hashed ID appears. This single hashed ID is a reference for the current commit. Let's switch branches to see how the head is moved to point to a new branch. Type git checkout testing and press enter. Next, type git branch and press enter again. This moves the head to point to the testing branch. Let me explain how this happens by using a diagram. We have two branches, the main and testing branch. When you run the checkout command, it moves the head to now point to the testing branch. To check the contents of the head file inside the .git folder, you have to enter the less command. Type less.git/head and press enter. You can now verify that the head has changed from main to testing. Now I will demonstrate how Git head works with a simple example. So I am here in the terminal. To see what branch I am in, I am running git branch. When pressing the enter key, I can see I'm on the main branch. To confirm that, I run the cat.git/head command and press enter. That brings me back to the reference to where it actually points to, namely refs/heads/main. In this case, you can see the reference is pointing to the head's main. If I change my branch to feature testing branches above, I use the git checkout command git checkout feature/testing branches. I then go to my head file inside the Git folder by typing cat.git/head. The ref is now pointing to the feature testing branches, namely refs/head/feature/testing branches. Notice that my branch is up to date with origin/feature/testing branches. I'll go back into my main branch by typing git checkout main and then check the reference file inside the main directory using the cat command again, cat.git/refs/heads/main. When I press enter, I get a hash ID. This is a reference to the latest commits of that working directory. I can show you that if you make a change to any files within this directory, that this ID will then change after a commit has happened. So let's do a simple update to the README file. You can do this with any editor such as VS Code, or I can also do this by executing the vim command. Type vim readme.md and press enter. When inside the README file, add some text. In this case, add minor update to your my first repo line and save it. Then check the ID again just to verify. Type cat.git/refs/heads/main and enter. If you would like to learn more about Vim, there is a link to an additional reading at the end of this lesson. The ID should be the same because we haven't committed anything. We've just made a change to run the cat command. Therefore, the ID is exactly the same as before. If I do a git status, it is telling me that I have modified the README file. On the screen, the words modified readme.md displays in red. I'll now add that file. The shorthand to add a single file is git add space dot. Type the command and press the enter key. I am then going to do a commit. Type git commit "-m for message by adding minor update to the command line and press enter. The data confirms that one file changed, there was one insertion and one deletion. I am using the cat command to verify what is in the reference file by typing cat.git/refs/heads/main. Press the enter key to confirm that the ID is changed. Originally, the ID started with a 8B55, and now it starts with 9C90. Whenever a change occurs for a commit, this ID will then update to be the latest commit for that working directory. And that's git head. You now know what the purpose of head is. You can also change the head to point to a different branch. Great novels are rarely written in one go, and usually endure several drafts before the author is satisfied with the outcome. Of course, there's always the possibility that an idea from an earlier draft will sound good again later. But without a system of organization, it can be difficult to find where this idea is located. Programming is no different, and sometimes you need to revisit old code. In this video, I'll guide you through how to use git diff to compare changes across your files, branches, and commits. You probably know that the git status command tells you which of your files have been changed. The git diff command goes a step further and tells you what exactly these changes are. When used together, you can think of them as a file system. Git status tells you the file names, but to open the file and see the contents, you'll need to use git diff. To demonstrate, let's say you have a text file named cities.txt, which contains the names of cities you visited. You've been updating the list during a tour of South America, but upon returning home, you've lost track of what you've recorded. So, what can you do? Well, this is a situation where git diff makes itself useful. Git diff will compare the previous version of the file with your current one to find any differences. It will then tell you specifically what content has been removed as well as what content has been added to the file. In your cities.txt file, git diff would tell you that you removed one city that was in version A and then added a new one that appears in version B. So, now that you've had a basic explanation, let's go into a more detailed example. In this video, I'll show you how you can use git diff. Diff is used to make comparisons against files on your local repository. It can also be used against commits and against branches. I'll start with a simple example. When I go into my local repository, I'll find a file called readme that I'd like to update slightly. You can do this with any editor, such as VS Code. I can also do this by executing the vim command to enter the file for editing, remove a few words, and then save it. If you would like to learn more about vim, there is a link to an additional reading at the end of this lesson. Next, I'm going to use the git diff tool to compare the updated file against the head. Because we haven't yet completed a commit, it's not available for a comparison against another commit. So, I'll input git diff, pass in the head as the first option, and then finally the file name. This then returns an output showing the changes that occurred in each file. Here, the line starting with a minus symbol represents what it originally was, while the line with a plus symbol shows what it is now. So my example tells me that the words minor update have been removed. In addition to individual files, you can also make comparisons against previous commits. I'll start by using the git log command to display my history of commits, and I'll also use the pretty flag here so that each one is shown in one line. The pretty flag is used by developers to make the output more readable. Each commit has its own ID code, so I'll perform a git diff command on the codes from the most recent commit and from the very first one. Git will go through all the files, note all the changes that have occurred, and return the differentiation between the two. Finally, one more way of using git diff that I'll show you is how to use it for making comparisons against branches. If I perform the command git branch, it will display all the branches that are available in the repository. I can then use the git diff command to pass in my main branch, followed by my feature branch as the second option. And once again, this will display all the changes that have occurred between the two. This shows that my feature branch has the previous update, while the main branch has the most recent one. So these are a few examples of how you can use git diff. In this video, you learned how to use git diff command to keep track of changes across your files, branches, and commits. This tool can help you to stay on top of updates and avoid mistakes or overlap. See you next time. One day, you might be overseeing a big team of developers. Can you imagine how complex it gets to keep track of everyone's changes and updates to files? Fortunately, Git has a very helpful command for keeping track of who did what and when. It's called git blame. In this video, you will learn about git blame, and I will demonstrate how it is used with a few examples. One of the core functions of Git is its ability to track and record the full history of changes for every file in the repository. In order to view and verify those changes, Git provides a set of tools to allow users to step through the history and view the edits made to each file. The git blame command is used to look at changes of a specific file and show the dates, times, and users who made the changes. By now, you should know how to use commands like git log to see the changes made. I will now use the feature.js file to demonstrate how git blame works. Let's get started with the git blame command. To run the git blame command, type git blame and the name of the file. In this case, feature.js. After pressing enter, Git returns a list of all changes on the file. To understand what is happening, let's break down the blame messages and go through it line by line. Firstly, let me guide you through the format of each line. Every line will start with the ID, and then the author, the date, and time when the change was made, and the exact line number where the change occurred. Then the actual change or content is also returned. The ID is a reference ID of the commit. The same ID might appear in several lines. This happens when a single commit has been made by the same developer. The author is the person who created the commit. The timestamp is the date and time when the changes were committed. Line number represents the location in the file or the exact line where the changes were made. The content is the code that was added to the file. Now that you know the meaning of each line in the blame output, let's explore a real example. In this example, you will check who made changes, when the changes were made, and also what changes were added. For the purposes of demonstration, I will be using a public repository called mkdocs. mkdocs has various different contributions from many different developers, so it's a good way to see a log file from all the changes of specific files. To begin, I will check inside the directory by using the ls command and passing in -l to get a list of all the available files, and I'll just pick one. The file I will use is called setup.py, which is a Python file. So in order to examine the different changes to that file, I create a command called git blame and then pass in the name of the file, setup.py, and press enter. The output will list all the changes made by all the different developers. It will also indicate the timestamps and line numbers as well as the actual changes that were made. Now I will talk you through the output. Starting from the left of the list is what's called a commit ID. It just represents the commit of when a change occurred. Then the name of the developer who worked on the file is listed, and then you have the timestamp when the change went in. Next is the line number in sequential order. And finally, the actual change that was implemented. I can scroll through the list of changes all the way to the end of the file, depending on the size of the file or whatever number of lines it has. If I want to exit out, I press Q. This will clear the screen to make it easier. Take note that git blame on its own and by passing the file name will list the entire file. In a lot of cases, you will work with very large files, and then you'll need a way to abbreviate the output or chop it down based on, say, line numbers. Fortunately, git blame offers a flag for that. To do this, I type git blame and pass in the flag of -l and specify the starting line number and the end line number. I will type 5,15, then pass in the file name again, setup.py, and press enter. This time, a smaller subset is returned that only starts at line 5 and ends on line 15. The output indicates that there are 4 different changes made by 5 different developers across these lines. Let me give you a few more tips around git blame now. Firstly, you can change the format of how the list is displayed. This is similar to what you can do with the ls command on the Unix commands. You can also pass in a -l flag for changing the output itself. So again, let's run git blame -l followed by the file name and press enter. This time, there are a few changes to the output. For instance, the commit ID is in its full-length form. It's not in the shortened version. The output is now a bit more detailed. You can also control if you want to show email addresses or change the date format. These are examples of the various things that you can do. Secondly, another aspect of using git blame is that you can see detailed changes or the actual commit changes of a specific commit ID. To do that, I will run a git blame command on that file again in order to copy a commit ID from the output. Now I will use that with git log -p and pass in the commit ID and press enter. This gives you the actual change that occurred. Just to clarify, git blame will display to you the point where it was changed. Git log will give you the detail of the change. I always use the two in conjunction to get more details about what changes occurred. You've reached the final video in this lesson on creating a repository with forking and the end of the Git module. Let's take a few moments to recap on what you've learned. You now know how to explain the principles of Git and utilize a GitHub repository, including branching and merging code. Perform a local install of Git on a Windows operating system. Create a new repository in GitHub and clone it to a local machine. Explain the fundamentals of Git and outline the Git workflow. And identify the differences between remote and local repositories in GitHub. Explain what the git add and commit commands do and describe how they work. Push content to remote repositories with git push and retrieve content from remote servers using git pull. Keep lines in your workflow clear and stable with the use of branches. And explain how head is used in Git to identify the current branch you're working on. Compare changes across files, commits, and branches using diff-commands. Examine changes to files and identify their author with the use of blame commands. And create a repository with the use of forking. You're now familiar with Git, GitHub, and creating repositories with forking. Great work! In this course, you were introduced to the practice of version control. Let's do a brief recap of what you covered. In the first module, you learned about how different version control systems and effective software development workflows enable modern software developers to collaborate across the world without messing up each other's code. You gained knowledge about the history of version control and know how version control or subversion is used to bring order to the chaos of massive software projects that have the potential for mistakes and bugs. Next, you learned more about the various systems, tools, and methodologies that are leveraged by software developers to collaborate successfully as part of a global team. You explored how to resolve conflicts in Git and that version control plays a crucial part in the development of software. You then moved on to investigate the difference between staging and production, and that a staging environment should mimic your production environment. In Module 2, you learned about how to use the command line to execute commands in Linux. You were introduced to what the command line is and learned to use commands that traverse, create, rename, and delete files on your hard drive. Then you learned how easy it is to use piping and redirection to create powerful workflows that will automate your work, saving you time and effort. Finally, you explored the command line further, discovering standard input-output streams, flags that can be used to change the behavior of a command, and grep. In Module 3, you developed a strong conceptual understanding of the Git technology and how it is used in software development projects to manage team files. First, you learned how to install Git on various operating systems, and then how to connect to GitHub via HTTPS and SSH before creating a GitHub account. Next, you gained a practical understanding of how Git works, including creating and cloning a repository, add, commit, push, and pull. You also explored how to use a repository and some concepts associated with workflows, such as branches, blame, and forking. Finally, the ungraded lab is an opportunity to complete a practical version control exercise by forking a repository, creating a branch, and committing a change. It also includes staging your changes and opening a pull request with the source repo. Well done on completing this recap. Now it's time to put into practice all that you've learned. Are you ready to proceed? Good luck. Congratulations on completing the Introduction to Version Control course. You've worked hard to get here and developed a lot of new skills during the course. You should now have a great foundation in the different version control systems and how to create an effective software development workflow. And you've also demonstrated your skill set by managing a project on GitHub for the graded assessment. Following completion of this course, you are now able to implement version control systems, navigate and configure documents, files, and directories using the command line, create and manage a GitHub repository, and manage code revisions. The key skills measured in the labs showed your ability to determine the current working directory and make and change directories and files using the command line, create, clone, commit, and push to a repository, create a repository with forking, and manage a project on GitHub. So, what are the next steps? You've established a good foundation so far, but there's always more to learn. Whether you're just starting out as a technical professional or student, this project will enable you to prove your knowledge and ability. Your project experience shows employers that you are self-driven and innovative. It also speaks volumes about you as an individual and your drive to continue your educational progress. Once you've completed all the courses in this professional certificate, you'll receive Coursera certification. Certifications provide globally recognized and industry-endorsed evidence of mastering technical skills. Congratulations once again on reaching the end of this course. It's been a voyage of discovery. Best of luck, and do continue to pursue your own learning objectives to their final goal.